Hello students, good morning. Now we are going to discuss about the module 2, that is dielectric materials and magnetic materials. So the first part of this module is dielectric materials. So before going to the topic, I want to recollect a few things regarding the materials. So in general, the solids are categorized into three different categories, that is semiconductor materials and conductors and insulators. How can we differentiate these kind of materials? It depends on the free electrons in it. If the electrons are free to move, then it is called conductors. If the electrons are not able to move, then it is called insulators. If the electrons and holes recombination is happening, then it is called semiconductor. Okay, so but the dielectric materials is different from all these things. This is another one category of material. It's like a insulating materials. So I'm repeating again, the dielectrics are insulating materials which do not have electrons, which means that free electrons. So what will happen, what is the difference? Anyway, I told you that there is some insulator is also there. So the what is the difference between these dielectrics and this insulating materials? So these kind of dielectric materials or dielectric materials, when we keep it in external electric field, or when we apply the external electric field to the dielectric material, it start to undergo the polarization process. Because of that, it forms the dipoles, and because of that, it can act like a conducting materials. Okay, so that is the important difference between the insulating materials and dielectric materials. Okay, so all the dielectric materials are insulating materials, but all the insulators are not dielectric materials. Okay, so now we will move on to dipole. So what is dipole? Here dipole is nothing but a equal and opposite charges is kept at a particular distance. A equal charge and equal and opposite charge, in the sense charge can be defined by the letter Q. So the plus Q and minus Q is separated by some distances L. So that is called dipole. So what is this is called dipole. So what is dipole moment? A product of any one of the charges, in the sense either we can take positive charge or negative charge. The product of any one of the charge with a distance is called dipole moment. So the dipole moment, now I'll share the screen also. Screen is also visible with you. The dipole moment is nothing but it is denoted by the letter mu. So mu, which is equal to Q into L. Here Q, what I told you, product of any one of the charges. So product of any one of the charges is either plus Q or minus Q. So what is the unit? We know that what is the unit for charge? Charge is coulomb, and length is nothing but meter. So the unit for dipole moment is coulomb meter. Okay, so this is about dipole. So once again I repeat, dipole is nothing but the equal and opposite charges is kept at a particular distance is called dipole. The dipole moment is nothing but the product of any one of the charge with the distance. So the unit for dipole moment is coulomb meter. So now we will come to polarization. So this is an important process in dielectric materials. So what is polarization? So as I told you earlier, when we keep the dielectric material into the external field, it start to conduct. That means charged particles, or there is a displacement of charged particles. So that process is called polarization. So I once again I repeat, when an external field is applied to the dielectric material, there is a displacement of the charged particles. So if the charged particles are displaced, and automatically it forms the dipole, and because of the dipole, and dipole moment is also produced. So this process is called polarization. So when we keep, once again I'll repeat because it's very important thing. If you know about the what is polarization, then easily you can able to understand about the dielectric material also. So dielectric material, when we apply the external field to the dielectric materials, the charged particles are start to move, and it forms the dipole, and hence dipole moment produced. So this process is called polarization. Okay, so now I think you'll get an idea and you about polarization. Now you come to the types of dielectrics. So there are two types of dielectrics are there. One is polar dielectrics and another one is non-polar dielectrics. So how can you differentiate polar and non-polar? The same thing. So in a dielectric materials, only we have the charged particle inside it. So it depends on the charged particle. We are going to define the what is polar dielectrics and what is non-polar dielectrics. So in polar dielectrics, the positive and negative charges are separated by a distance, which means that the positive charge can be any molecule or negative charge can be at any molecule, and the both are separated by some distance. So that is called polar dielectrics. Once again I repeat, the polar dielectric molecule, the positive and negative charged molecule are kept at a particular distance. In the absence of external field, now we are not sending any external field to such kind of polar dielectrics. In the absence of the external field, the dipoles are oriented randomly and net zero dipole moment for the material is 0. So which means that in the absence of the dielectric material, in the absence of the external field, the dipoles are oriented randomly, so that the net dipole moment is 0 for the polar dielectric material. So the same thing is going to happen in a reverse direction for the non-polar dielectric material. Can anyone, so you can easily give the example for dielectric materials also. So dielectric materials, what I told you, the positive and negative charge is kept at a particular distance. Am I right? So if positive and negative charge, any molecules can you easily able to explain? So like hydrogen and chlorine. So hydrochloric, that is called, what is that, HCl or H2O. So H is positive and O is negative. So that is also coming under polar dielectric material, which means that water. So positive and negative charges kept at a particular distance. If you come to the non-polar dielectrics, so polar dielectric I told you positive and negative charges is kept at a particular distance, but in a non-polar dielectrics the positive uh, the center of the positive charge and the center of the negative charge do not coincide with each other, which means say that they both neutralized each other. Such materials are called non-polar dielectrics. So example for non-polar dielectric is O2 and H2. Okay, so examples are not given in the book, you can note down. For polar dielectric materials, the example is water, H2O, and non-polar dielectrics, the example is O2 and H2, oxygen and hydrogen. Okay, so next we'll move on to the next topic, the dielectric constant. So dielectric constants, whenever if you see any kind of the dielectric material, dielectric intensity, we must know about what is the dielectric constant also. So the dielectric constant is nothing but a constant which we introduce to remove the proportionality constant and which defines about the dielectric material's property also. So for isotropic material, the electric field strength and flux density, the both are related with the formula D, which is equal to epsilon naught epsilon r into E. So what is very much needed for the dielectric material? I told you the external field E is very much important. Now we are discussing about the flux density. The flux density is denoted by the letter D, capital D. So what's the relation? So capital D, which is equal to epsilon naught epsilon r into capital E, which means that epsilon r is nothing but the permittivity of free space. 0 is nothing but free space, it's a constant, and the epsilon r is relative permittivity, that is epsilon r relative permittivity, it depends on the medium, and E is a electric field. So when we talk about the dielectric materials, we must know about what is dielectric density also. So that what they have given with the with this relation. Now we will move on to the electric polarization and dielectric susceptibility. So what is electric polarization and what is dielectric susceptibility? So before going into the topic, I want to explain about the dielectric susceptibility. Polarization, because already we know that polarization. So polarization is nothing but, once again I'll tell you, when a dielectric material, if we apply the external field to the dielectric material, so the charged particles are move apart and it forms the dipoles, and hence dipole moment produced. That process is called polarization. So but in the case of dielectric susceptibility, how to explain it? So we know that there will be two slabs we are going to consider, which means that parallel slab, one which is on the sides it consists of positive ions and another side it consists of negative ions. The both slab is separated by a distance small t. Okay, so dipole moment, what is a dipole moment? I told you, any one of the charge, the product of any one of the charge with a distance. Now I'm going to write the same dielectric dipole moment relation for this slab also. So that what here they have given. You can see that thing in the screen also. The total dipole moment of the material, the charge into distance of separation. So here distance of the separation they have mentioned with the letter small t. So mu, which is equal to q into t. So one more relation I want to take it into the picture, that is nothing but polarization. So polarization, already we know that the what is that definition for polarization, we know that, but now I want to explain in terms of formula. That is, what is exactly they have given is the dipole moment of the material. So what is a dipole moment? Dipole moment can be written with the letter mu by volume of the material. So volume of the material is V. Okay, so how we can elaborate the dipole moment? The dipole moment is written as q into t, and volume of the material is, we can write the thickness, which means that the distance into a area. So t will get cancelled and only we will get q by a. So what is a unit for q? The q is nothing but it charge. What is the unit for charge? That is coulomb. And what is the unit for area? It's meter square. So what's the formula for polarization? P, which is equal to q by a, and what is the unit? That is coulomb per meter square. Okay, so directly we can tell that the polarization is highly depends on the electric field, the applied electric field E. So we can say that the P is directly proportional to E, that is applied field. To remove the proportionality symbol, we are introducing the constant that is called epsilon naught and chi. Epsilon naught for the free space you can easily add, because now we are not considering any kind of material here, so we have to consider that as a free space, that is epsilon naught. And chi is the dielectric susceptibility, that is nothing but a constant. So P, which is equal to epsilon naught chi into E. So chi is a constant which we are introducing in terms to remove the proportionality symbol, and chi in otherwise, or chi in other words, we can write P, which is equal to epsilon naught into epsilon r minus 1 into E. So epsilon r minus 1, already epsilon r is there. So instead of chi, what I am writing? Instead of chi, what I am writing? Epsilon r minus 1 into E. In terms of vector format, we have written here. So once again repeat, what is the relation between the polarization and electric field means? We can write this formula which is given in the bold letters. That is P, which is equal to, P is nothing but polarization, and epsilon naught into epsilon r minus 1 into E. E is an electric field. Don't forget this formula. This is very important formula. In the numerical point of view, we will use this formula whenever it is required. Is it clear? Now you come to polarizability. So what is polarizability? So the same thing, how whenever if you see the susceptibility, the word susceptibility, polarizability, it looks like a constant only. Okay, so here also the polarizability is nothing but it's denoted by the letter alpha. So dipole moment acquired by the dielectric atom or molecule is proportional to the applied field, which means that the dipole, we know that the dipole moment is directly, polarization is the, if polarization is directly proportional to electric field, obviously the dipole moment is also directly proportional to electric field. So now we are going to take that into the consideration, that is dipole moment is directly proportional to electric field, and this proportionality symbol again, whenever it is removed removed, we need to introduce one constant. That constant is termed as polarizability alpha, mu which is equal to alpha into E. Here alpha is a polarizability. So similarly, chi is what? Susceptibility. Alpha is what? Polarizability. So what is the unit for polarizability? That is nothing but Fermi meter square. So these are the things you have to remember. So these are the basic definition and relations before going to start this further explanation. So once again I want to repeat all these constant term and equations. So first equation what we have seen is dipole moment. So what is the dipole moment? The dipole moment is nothing but the product of any one of the charge into distance. So dipole moment is denoted by the letter mu, which is equal to q into L. So q is charge, which is denoted by the unit coulomb, and length is meter square. So the unit for dipole moment is coulomb meter square. So second thing what we have seen is polarization. So the polarization is nothing but when an external field is applied to the dielectric material, the charged particles start to move apart. It forms the dipole and hence dipole moment produced. This process is called polarization. So when we talk about the polarization, we must know about the flux density also. So for flux density, it denoted by the letter capital D, which is equal to directly proportional to the electric field. To remove the proportionality constant, again we have introduced two different constants, that is epsilon naught and epsilon r and capital E. So epsilon naught is a free space, that is permittivity of free space, and epsilon r is a relative permittivity. So D is nothing but flux density. Okay, that is a formula number 2. And formula number 3 what we have seen is polarizability. So polarizability, before that we must know that polarization is directly proportional to the electric field E, or we can say dipole moment also, that is noted. So polarization is denoted by the formula Q by A. From that we have written the unit, that is coulomb per meter square. So what is the unit for polarization? It's coulomb per meter square. So if you want to introduce the constant term to remove the proportionality symbol in polarization, so we have introduced the susceptibility term, that is epsilon naught into chi into E. Chi again we have written as epsilon r minus 1. So what is the third formula? P, which is equal to epsilon naught into epsilon r minus 1 into E. So that is the formula number 3. And last and final formula is polarizability. So polarizability, again the dipole moment acquired by the atom is directly proportional to the electric field E. So moment, dipole moment, which letter we have denoted? That is denoted by the letter mu, and it is directly proportional to E. So mu, which is equal to remove the proportionality symbol, we have introduced the constant, that is called alpha. So mu, which is equal to alpha into E. So what's the formula for polarizability? That is nothing but Fermi meter square. So whenever you study the equation, don't forget to study the unit also. So that's all about the introduction part. Thank you. In next class, next video, we will discuss about the types of polarization.